Hello, this is Mr. Brooks and welcome to Lesson 2.5, Proving Angles Congruent. We're going to prove angles congruent and we're going to apply theorems. Okay, the first term you need to know in Lesson 2.5 is theorem. A theorem is something that has been proven to be true. Our first theorem we're going to look at is the vertical angles theorem. Vertical angle theorem simply states that if you have vertical angles like angles 3 and 4, that they're going to be congruent. When we want to use the vertical angle theorem, of course we will never say theorem 2-1 because as I explained to you in class, you can never use the numbers for postulates or theorems. We will simply write down VAT for vertical angle theorem, if ever you want to use that to justify something in a proof, which is our next topic. This is what the start of every kind of proof is going to look like. We're going to look at 3 or 4 different kinds of proofs in this class. But every type of proof always starts with given information, which is what you know, and what you're trying to prove. And they will always have a diagram for every type of proof. The type of proofs we will be looking at in this class are paragraph proofs, 2-column proofs, flow proofs, and indirect proofs. You don't need to learn these yet. I just thought I would introduce the different types of proofs. Here is a sample of a paragraph proof trying to show the vertical angle theorem to be true. Vertical angle theorem states if you have vertical angles, like angles 1 and 2, that they must be congruent. Alright, so we start with vertical angles 1 and 2, that's given, and we're trying to prove angle 1 is congruent to angle 2. Well, if we look at a paragraph proof, we know that angles 1 and 3 add up to 180. Why? Angle addition postulate. If you got a straight angle, the angles add up to 180. And for the same reason, angles 2 and 3 are going to add up to 180. Well, if 1 and 3 equal 180 and 2 and 3 equal 180, then hopefully you'll agree 1 and 3 have to equal 2 and 3 by substitution. Then when you subtract the measure of angle 3 from both sides, you get measure of angle 1 equaling the measure of angle 2. Or angle 1 is congruent to angle 2. Again, you don't have to learn how to do proofs in Chapter 2. We're just trying to introduce them to you. One thing you do need to learn in Lesson 2.5 is how to use the vertical angle theorem, in this case, to solve for x. Well, since we know that vertical angles are congruent, we know that these two angles are going to be congruent from the vertical angle theorem. So, 4x is going to equal 3x plus 35. And then we'd subtract 3x from both sides, and we would get x to equal 35, which is what we were trying to find. Quick check number 1 asks us to find the measures of the angles. Once we find x to be 35, we can plug x back in to the measure of the angles, and hopefully you'll agree that this angle is 140 because 4 times 35 is 140. Then we multiply 3 times 35, we get 105, and add 35, and this angle is also 140. And we've got our vertical angles are congruent. Quick check number 1, part B, asks us to find the measure of these two angles. And so, if that's 140, this must be 40, and this must be 40. Because we know, form a straight angle, they got to add up to 180 from angle addition postulate. Congruent supplements theorem states if two angles are supplements to the same angle, or of congruent angles, then the two angles are congruent. What this means is, if we have angle A that's 50 and angle B is 130, hopefully you agree, angles A and B are supplementary angles. And if C is a 50 also, well, then B and C are supplementary angles. So we have A and C both being supplements of B. Therefore, A and C are congruent. Also, if we look at angles D and E, they are supplementary angles, and F and G are supplementary angles. And since both E and F are congruent, they both measure 160. And if D is a supplement to E, and if G is a supplement to F, then D and G must be congruent because they are supplements of congruent angles. The exact same thing can be said about complementary angles also. The congruent complements theorem states that if two angles are complements of the same angle, or of congruent angles, then the two angles are congruent. Here we have A and C are both complements of B. Complementary angles are two angles that add up to 90 degrees. So A and C are both complements of B, therefore they are congruent to each other. Now we have D and E being complementary angles, and F and G being complementary angles. And since E and G are congruent to each other, and D and F are complements of those congruent angles, E and G, then D and F must be congruent because they are complements of congruent angles. The last two theorems you need in lesson 2.5 are all right angles are congruent. And hopefully that makes sense to people that if all right angles are 90 degrees, they all have to be congruent to one another. And if two angles are congruent and supplementary, then they have to be right angles. If two angles are equal and they got to add up to 180, then they would both have to be 90s. So they would both have to be right angles. Hopefully that makes sense to you as well. Now before we finish up with Chapter 2, I want to take another look at a sample proof, a sample paragraph proof. Again, we're not doing proofs in Chapter 2, we're just introducing them, but we're going to be doing a lot of them later, so let's take a look at this one. We know that angles 1 and 2 are supplementary, that's given. Angles 2 and 3 are also supplementary. So how would we be able to prove angle 1 and 3 are congruent? Well, as you can see in the paragraph proof below, if two angles are supplementary, they got to add up to 180. So 1 and 2 have to add up to 180, and 2 and 3 have to add up to 180. Then by the substitution property, we could say 1 and 2 have to equal 2 and 3. And then when we subtract angle 2 from each side, we get angle 1 congruent to angle 3. This concludes lesson 2.5.